Given that 1 over 1 minus x equals the sum from n equals 0 to infinity of x of n, this is basically the geometric series formula where the a is 1 with convergence -1 to +1. Find the power series for this with center 2. Well, how do we do that? Well, I'm giving a nice hint here because this is a little bit tricky. Here's an example of 5 minus. We have 6 minus x. Shouldn't be much different. With center 2, hey, same. Well, we got a nice hint. We must produce an x minus 2 term. See, whatever your center is, you've got to have an x minus that term. You got to make that appear without changing any actual values. So you say, okay, take the thing they gave you and then replace the x with x minus 2 plus 2. See, that's still just x, isn't it? See how that's what I call plastic surgery? We remove the wrinkles. It got a new look, but it's the same value. X minus 2 plus 2 is still just x. Then you can distribute this 5 minus that 2. And then you get the other part. And then that's 3. Now divide all the terms by that 3. You get this. Put this 1/3 in the front. And boom, you've got it in the right form to do this thing. All right. Let me show you. Let me just do it right here with you. So we're going to say, okay, um, we have 1 over 6 minus x. What do we need? We have center 2, so we gotta make that appear. So I'm going to go minus x minus 2 plus 2, just like they did, right? And that's still just x. Right? I'm doing plastic surgery, giving it a new look, same value. So I can do my formula thing. I need to make it look like the formula, right? See how in the end we've got to make it look like this with a 1 here and a 1 here and some x stuff here. Need a 1 here and a 1 here. Whatever the x stuff is, I can plug in. But I need this to be a 1 and this to be a 1, right? Got to give it that look. That's what we do in math and science. Physics, chemistry, same kind of thing. So what we do, they give us a formula and we think, okay, here's the formula I need to use. That means I got to make it look like the formula, 1 here and a 1 here and something there which I'll plug in. So we can't have like a 6 here or a 5 here or something else. Got to have a 1 here, 1 here, 1 here, and then whatever the x is there, plug it in. Okay, so let's keep going. So this is um, 1 over 6 minus 2 minus x minus 2. Does that look weird to you? What I did is I grabbed this one and brought him outside. You might think, no, you didn't. You grabbed the other one. No, I didn't. Because that's the minus, right? So that minus applies to everybody, including this guy. So that's a minus 2. That's him right here. He came, so this guy came right here. What if I show it that way? He went right there, right? Because it's 6 minus, and he came out there. Okay, and then still minus the other x minus 2, right? And so now that gives us, so that's 4. 6 minus 2 is 4 minus x minus 2. And then we go over 4, over 4, over 4. Why? I was trying to make that a 1 there, right? So that'll be 1/4. This will be 1. This is now 1. We need to get a 1 there. Minus x minus 2 over 4. Think, yeah, but now we got a 1/4 in the top. But yeah, that one we can just pull to the front, right? Sorry, that 4 looks terrible. We go times. This can just be a 1 up here. 1 minus x minus 2. For now, this has the look we want. We didn't change any values, right? Everything I brought in, there was no change. Just looks different. See, now it has the right look. We did the plastic surgery, right? It's got a 1 here and a 1 here and some x stuff there, so we can use this formula. And whatever the x stuff is, we just plug it into right there. All right, there's the trickery, the sorcery. Well, it's plastic surgery. All right, so I'm gonna plug into this formula now. What does that formula say? It says if you have 1 over 1 minus x, whenever we have x in a math formula, science formula, same thing. That means that's the plug-in side. It's the holes in the toaster. It says you can plug it into this formula, the sum, what does it say? Of x to the n, right? So that's what it says right up here. Sum of x to the n from n equals 0 to infinity. 0 to infinity. That's the geometric series formula. So that means whenever you have that format, you can do that. So I've got that and I can do that. So I will now do that. I've got, um, here, let's do this. Whoops, pushing the wrong button. It's all over the place here. This is my x. So that is going to be where I plug in x minus 2 over 4. And I got to pop a 1/4 in the front because I really have 1/4 times that 1. Just multiply both sides by 1/4. And then put in here x minus 2 over 4. Does that make sense? So I took this geometric series formula they gave me, multiplied both sides by 1/4 because that's what we have. And I plugged in for the x in both spots. X minus, in fact, I think I can say that better. Let me try that again. I was kind of stilted. Let me try that again. So we've got 1 over 1 minus x equals, that's what that formula says, from n equals 0 to infinity of x. And it says if you ever have anything of this form, you can plug it in there, right? That's what a math formula, science formula says. Well, so first off, here's what I have. So I've got to I got to multiply both sides by 1/4. I'm going to make this left side look like this. So I want to know, what does this equal? This is what I have. And then I'm going to plug in for the x. X minus 2 over 4 for the x, right? Well, I'll just write it that way. X minus 2 over 4. Sorry, I'm just getting scribbly. Okay. Goes right in there. Or the x goes right in there. It's plugging x. So what does that equal? So this equals 1/4 times the sum, n equals 0 to infinity of x minus 2 over 4 to the n. Right, I plugged it in for x to the n. Can I clean that up a little bit? I can do a little bit. You can make this x minus 2 to the n over 4 to the n, right? You just do that in power, top and bottom. Sorry, I wrote that scribbly. Right, that in power goes to the top and the bottom. And then this 1/4, I'm going to put them right there. Right? Just let this 4 go right in there to the bottom. It's on the bottom. So that is what? That's the sum. I'm going to quit writing all that stuff. X minus 2 to n over 4 to the n plus 1, because that's 4 to the 1. Right? Same basis, powers add. Boom. Is that what they had? That's what they had. X minus 2 to the n over 4 to the n plus 1. So we got that. We got that. Now that we got that, now it says, okay, now identify its interval of convergence. Where's it convergent? Like, okay, we know that 1 over 6 minus x can be represented with that power series, a power series, infinite polynomial, right? It's an infinite polynomial, right? It goes from up to infinity, from n equals 0 to infinity, adding up these terms forever. An infinite polynomial centered at 2 has an x minus 2 term. And but it's going to converge. This infinite polynomial, this power series, is the same, is equal to 1 over 6 minus x, not for all x values, but only for certain x values. In fact, you can see the answer here. For x values between -2 and +6, not for all x values. Well, how do we know that? Well, that's what we're trying to find out. So we started with the power series formula they gave us. And they said, if you ever, anything of this form, 1 over 1 minus x, you can say it's equal to this power series, but that power series only converges for values between -1 and +1, right? That means when x is between -1 and +1. That's what that's saying right there, right? It's saying the original formula they gave is saying this formula is true. 1 over 1 minus x equals a power series, the sum of x to the n, and it converges, meaning they have the same answer. They converge, that infinite add them up forever thing has a finite answer, converges to an equal finite answer as long as x is between -1 and +1. What is x? X is the thing you're plugging in. So we just go, oh, what was the thing I plugged in for x? It's this. So this converges. I'll do it right here. This converges when the x, which is x minus 2 over 4, is between -1 and +1, right? See how I got that? That's what this says right here. That's what they said. I'm just taking their words. They said this formula will equal this power series. It'll converge to be the same as long as x, the thing you plug in, x is just holding a spot in all math science formulas. The thing you plug in is between -1 and +1. So I took that formula and I plugged in for x minus 2 over 4. So really, I should have brought this down here. Let's do it. So it converges. I got to do the rest of the work. When? So again, -1, and then the x minus 2 over 4 plus 1. All right, let's solve it. How do we solve it? So we got to solve for x. I'm going to multiply through by 4, 4, 4. Cancels out there. Times 1 is 4. -4. Add 2, add 2, add 2. Boom. X is between 6 and -2, between -2 and 6. Converges between -2 and 6. Now, what about the image? They're both a no niner. I don't even need to check nothing. Why not? Well, because they told me right here. I'm just taking their words. It only converges when x is between -1 and +1. Not equal to the endpoints. Only between the endpoints, right? This doesn't have an equal sign. It's not equal to -2. It's not equal to the other one. No, just in. So that means endpoints are a no niner. No, endpoints, no. That I'm just taking their words. Now, there's other times when we do power series work and we do have to check the endpoints. And see I can see where that'd be confusing. I say, Mr. Harris, sometimes you check them. Yeah, true. Sometimes we do, but we don't when they explicitly give us this and they tell us, here's where it converges, boys and girls, right here, nowhere else. So I don't need to guess, right? Where's it converge? Does it converge at the left rim? No, it said it doesn't. So that's it. And that's, by the way, that's because it's a geometric series. If you look at my notes right here, power series by use, this is the formula we just used, right? Notice below in the given statement that when using that, the interval of convergence is this left and right not included. So I'm just telling you that in the notes as well. So the left and right are not when you're using this formula, which is from the it's a geometric series formula is what it is. If you look back to when we did geometric series stuff, the endpoints are automatically no and no. I don't need to check them. So there we go.